Hi, this is the grumpy old IT guy. Welcome to Module 4, Lesson 5, where we learn how to create and manage indexes. This is an important topic related to the table management topic. Indexes will greatly improve query performance. Too many indexes can actually hurt query performance. We will touch the basics of index management and see how some queries can benefit from the indexes by generating and examining query plans. Query plan generation is possible by using a tool available in the SSMS menu bar. Take it away, Assistant Professor Nigel.
Here is our objective. In this lesson, you will learn what indexes are and how to create and manage them. Additionally, you will learn how Tsql queries use them when processing data. As with database tables, you will learn how to create indexes with SSMS and Tsql DDL commands.
We will follow the same approach as in the prior two lessons. Why change now? We will learn how to create indexes with both SSMS and Tsql. Next, we learn how to drop indexes with SSMS and Tsql. Last, we take a look at how to alter indexes with SSMS and Tsql. Let's start by discussing how indexes work, specifically how they are structured. We will also look at the different types of indexes. By the way, there are quite a few. Specifically, here is what we will cover in the lesson. How indexes work by traveling down B trees. Creating non-clustered indexes with Object Explorer. Creating clustered indexes with Object Explorer. Creating unique clustered indexes with Tsql. Creating non-unique clustered indexes with Tsql. Creating unique non-clustered indexes with Tsql. Creating non-unique non-clustered indexes with Tsql. Query plans. As we can see, there are two indexes, unique and non-unique. Additionally, there are two other categories of indexes, clustered and non-clustered. I will summarize the lesson by showing you how indexes are used in a query plan. A query plan is a graphical display showing how the optimizer and query engine use or don't use indexes. Indexes are critical data objects that are used to increase query performance. Index structures are inverted tree structures that contain nodes that either point to other nodes in the tree hierarchy, or to the actual data rows themselves. For example, take a look at the clip. Let's assume we have a table with 7 rows and wish to retrieve row number 5. Assume the critical value is 5. Animations. Without an index, we would need to perform a sequential search until we get to crucial value 5. With an index, starting at the root node, we ask, does 5 equals 4? No. If 5 is greater than 4, branch to the correct node. Does 5 equal 6? No. If you branch to the left, does 5 is equal to 5? Yes. We have found our row. If we have an index, we only need 2 comparisons. Once we reach the leaf node, we retrieve the pointer to the row, follow it, and you have reached your target row. Okay, 5 searches versus 2. Big deal. But imagine if the table has 500,000 or more rows. So, how is this accomplished? An index structure, called a BTREE, is used. Take a look at the matrix in the clip. A BTRE with 5 levels can access up to 32 rows. A BTRE with 15 levels can access 32,768 rows. In the worst case, only 15 traversals and comparisons of the value down the inverted tree hierarchy are required to reach the last row with the critical value. A BTRE with 20 levels can access 1,048,576 rows. In the worst case, only 20 traversals and comparisons of the value down the inverted tree hierarchy are required to reach the last row with a crucial value. If there were no index, there would have to be up to 32,768 comparisons and sequential searches until you reach the last row. This depends on whether or not the fundamental sorts the table and no indexes exist. Try it yourself. 2 to the second power equals 4, 2 to the third power equals 8, and so on. Indexes can also be created via Object Explorer or Tsql. If we right-click on the indexes folder in the database we are working in, we can create a new index by clicking New Index. 7 basic index types are available, but we are only interested in clustered and non-clustered indexes for this module. Clustered indexes mean the index is physically attached to the table, and the table rows are in the same order as the index. It makes for a fast performance. Non-clustered indexes are physically separated from the table, and once the desired node is reached, an extra pointer is required to get the row. Let's create a non-clustered index with the Object Explorer tool in the following clip. If we select the non-clustered index type, a dialog box is presented. We see the table name, default index name, and index type filled in. Here is a grumpy tip alert. It is recommended to rename the index as the default name is pretty ugly and needs to convey meaningful information about what the index is for. It is good practice to give your indexes a meaningful name and use prefixes like PK for primary key and FK for foreign key or AK for alternate key at a minimum. Working in the table name and column helps, too. There is IE for inversion entry also. This is another path the query optimizer can follow to retrieve the rows. Next, specify whether or not the index is unique or not by clicking the Unique checkbox. Next step, select the index key columns and sort order. The data type, size, whether it is an identity column, and whether or not to allow nulls. This is filled in for you based on the table metadata, by the way. You can also include other non-index related columns in the Included Columns tab. What does that mean? In addition to the columns required for an index, you should include one or more columns that you know will be used in queries that access the table the index is based on. Why do we do this? Because this increases performance.
Grab a cup of coffee, gang. Here comes our next demo. Take it away, Professor Grumpy.
Okay, let's do our first demo here. We're going to start by creating a non-clustered index. We're going to do this with Object Explorer. We are going to use the sales data warehouse. And I'll pick on the sales history table. If we right-click on it, look at the properties, it's not that big of a table in the scheme of things. I mean, it's got, let's see, 324,000 rows, so that's fairly big. Ideally, we would want to have a couple of million rows, but since this is a demo database, okay, I don't want you to take hours to create it when you download the code to initialize this. And let's see, it's got customer key, product key, calendar key, then it's got the measures, right? It's a data warehouse. So the measures are transaction quantity, transaction amount, and sales tax amount, right? So we would want to create a non-clustered index on probably all of these surrogate keys. We'll call them the customer key, the product key, and the calendar key. So we'll just do one, and you can do the rest. You would also create one clustered index that includes all those 3 keys, because again, since this is a data warehouse, you're going to be working with what's called a star schema, right? You're going to join those dimensions. Let's see, sales history only has 3, so that's a good choice. Let me just look at sales transactions, for example. So here we have more keys, right? This is like we'll call it the bread and butter fact table. It's got a surrogate key for customer, product, country, store, and calendar. But we'll just do this one for the demo, and maybe that's a good exercise for you in one of the homework assignments. But anyway, so how do you create a non-clustered index with Object Explorer? Well, right-click on Index, New Non-Clustered Index. That's what you select. All right, add at least one index key to the index. So what we need to do here is basically start filling this in. So look at that ugly non-clustered index name. We're going to give it a better name. We'll call it, let's see, inversion entry. Let's see, customer key. Keep it simple. Okay. It's non-clustered. It's not unique. So we'll add a key. And whoops, it went all the way over there. We'll add the customer key. And we'll just click on OK. That little error message disappeared. Pretty much that's all that there is to it. Notice that it's integer data type that we added. It's 4 bytes. It's not an identity key, and nulls are allowed. Well, technically, we really don't want nulls allowed. Let's see if I can change this here. No, doesn't look like I can. So anyway, let's just click on OK. And this will crank a bit. But it created it. Was quick. There it is. Might as well, oops, and look what I did. I misspelled it. Let's correct it in the usual quick way. And that's it. I'm about to rename it. Yep. So now it's spelled correctly. So that's basically how you would create a non-clustered index, all right, with SQL Server Management Studio. Let's create a clustered index while we're here. Well, actually, let's go back to our lesson. That's probably our next demo. So we just want to go back to our lesson before we attempt this.
Please navigate to the index folder again, right-click and select Clustered Index from the menu. Make sure to give it a good, meaningful name. Remember the prefixes. PK for primary key index, FK for foreign key index, AK for alternate key index, IE for inversion entry index. Using these prefixes or placing them at the end of a suffix will help anyone maintaining these indexes understand how they are used. If we select the clustered index type, another dialog box is presented. We see the table name, default index name, and index type filled in. Reminder: it is recommended to rename the index as the default name is pretty ugly and needs to convey meaningful information as to what the index is for. Use something like pk_grumpy index. Yes, that's smashing! Then, you can specify whether or not the index is unique by clicking the Unique checkbox. Next, you can select the index key columns and sort order, the data type, size, whether it is an identity column, and whether to allow nulls. Recall this is filled in for you based on the table metadata. You cannot include other non-index related columns in a clustered index. Why? Because the index is already part of the table, and all the columns are there.
Grab a cup of coffee, gang. Here comes our next demo. Take it away, Professor Grumpy.
Okay, here's our demo. We're going to create the clustered index with Object Explorer. This time we'll be using the sales table in our data warehouse. Just as we did before, we will right-click on indexes, create a new clustered index this time, and we'll give it a nice name. We'll call it, let's call it AK, alternate key sales index. Okay, I'm being very liberal right now with my names, you know, not making them too descriptive, but we'll add a whole bunch of columns, and there it is. It's popping out of the field division, but we'll add we'll add all of these columns, all the key columns, that is the surrogate key columns, and they all allow nulls, so that's why it's a not a unique clustered index. So we'll click on OK. All those columns have been added. We do have some options here. Sort in temp DB. Why not? Let's say true, right? So if you have a very fast disk for temp DB, that'll definitely optimize things. You can put in the fill factor. What that means is how much do you want the basically the index page to fill up before you start a new page. All right, so you always want to leave a little room, but that's kind of an advanced topic for DBAs, so we'll skip it for now. Is there a file group that we can pick? Sure, we'll pick the fact file group, okay, because we don't want this to go to the primary file group. It is a fact table, and extended properties basically allow you to, just kind of add some columns. I'm sorry, some comments. So we'll leave that alone for now. So let's just click on OK, and this might take a little longer than the other one because it's a clustered index. It's going to sort the rows in the order of the index of the new index. There it is right there. And let's execute this query. The reason I put this query here is so we could see if that index is used. We'll free up the procedure cache, so we know we're not cheating. We're starting off with a clean slate. There's no information in the procedure cache that might help the query. So we'll free it with the dbcc command. Okay, it just gives you a bunch of information. Let's highlight our query. Let's look at the query plan. Okay, this looks good. We are adjoining two tables. Notice that there's a clustered index seek on the calendar table. So if we go to this calendar table up here, where is it? The dimension calendar table, and it's got a whole bunch of indexes, and we're using the new index. Now look what happened. Although it's using these indexes, it's saying, hey, there's still a missing index. That's in the green font there. So let's right-click on that message and say click on missing index details, and we'll copy and paste the command. But before we do that, it'll improve the cost by 92%. Wow. All right, let's take the whole code that was generated. All right, we're going to basically go right down here, and let's create this index. Let's give it another name. We'll call it, okay, alternate key sales index. I'm just going to, this is not a good name, but I'll add QH for query hint. Okay, just so we don't get, we don't get confused. But notice that we're only creating it on the calendar key, because this particular query would take advantage of, there's a filter here, so it would take advantage of that index, if there was one, a lot better than the other index we created. All right, so let's just go ahead and create it. And then let's rerun that query plan and see if it's now using this index. Getting into a little performance tuning here. So which one is it using? It is now using our new query hint index. Let's execute this query. Notice that when I hover over the task, a pop-up appears that tells you the steps involved in that task. We are only seeing a few of them because they're cut off at the end of the viewing area as I'm recording this, but try it on your own. So let's execute this query, and boom, 21,000 rows in under 1 second. So that was a pretty good enhancement. Now technically I was supposed to free the procedure cache and then do the query plan. It's a little performance tuning here because we're dealing with indexes. So you see the cost of each task, which is a blended cost of memory and CPU and storage. So an index seek, a clustered index seek, then a nested loop to basically join everything up. So we'll free the procedure cache once more and go back to our lesson.
Creating unique clustered indexes is the same as the prior case, except that we include the unique clustered keyword in the create index statement. This Tsql command creates a unique clustered index named pktransaction on the core.transaction table with the following columns in ascending order: transaction date, transaction ID, producto, transaction amount. Explanation of each part of the command. Create unique clustered index pktransaction. This statement creates a unique clustered index named pktransaction. On core transaction specifies the table core transaction on which the index is being created. Transaction date ASC, transaction ID ASC, product no ASC, transaction amount ASC, specifies the columns included in the index and their sorting order. In this case, the index will be sorted in ascending order based on transaction date, transaction ID, product no, and transaction amount. With clause, this clause specifies additional options for the index creation. Here are the options specified in this command. Pad_index equals OFF specifies whether the index padding is turned off. Statistics_nor compute equals OFF specifies whether statistics are recomputed automatically. Sort_in_tempdb equals OFF specifies whether to perform index sorting in the tempdb database. Drop_existing equals OFF specifies whether to drop an existing index with the same name if it exists. Online equals OFF specifies whether the index can be created online. Allow_row_locks equals ON specifies whether row level locks are allowed. Allow_page_locks equals ON specifies whether page level locks are allowed. ON_trans_fg specifies the file group trans_fg on which the index will be stored. This command creates a unique clustered index on the specified table with specific columns and options to optimize data access and storage. Grumpy tip reminder: have a dedicated file group and associated files for indexes to speed things up. Partitioning tables across physical disks, advanced topics, is also essential. Grumpy alert: these will eat up much space.
Grab a cup of coffee, gang. Here comes our next demo. Take it away, Professor Grumpy.
Okay, let's create a unique clustered index. All right, here's our demo. Topic 4, unique clustered index with Tsql. What we're going to do is drop this sales transactions tables. That's why I created it, just so we could include only rows that had all of the keys defined. So we will drop this table. Dangerous. Still appears here, but if we refresh the folder, it's basically gone. And I'll prove that to you. Refresh our folder. and that sales transaction history table is gone. So what we're going to do is we are going to select all of the rows from the fact sales table, but distinct rows. So we're guaranteed to not get any nulls in there. We're going to uncomment the into. So it's going to be a select into. And I like to be consistent. Let's just make this in uppercase too. Looks a lot neater. And just get all the distinct rows, 32,400. So we didn't have to do that actually, getting the same row count. So now we could drop the index if it exists. Okay. Then we can create it. Now it doesn't exist because we just dropped the table. So we're going to create that unique clustered index. There's the keywords. Create unique clustered index, PK for primary key for sales transactions, okay? So you can name it the same as the table if you want. On the sales transactions table, fully qualified name. And we're going to include all of those surrogate keys that's typical in a fact table. So now if we refresh it, there's the, where is it? The sales transaction history table, sales transactions table that we just created. And there's all those surrogate keys. So let's create this index. See how long this takes. We're into 5 seconds, 6 seconds, not too bad. Drop, all right, I'm not going to drop all these other indexes on the calendar. They already exist. That's, we could recreate it, but I'm not going to do that. You can try that yourself. So I'm going to free that procedure cache. Let's highlight the query. So this is a very complicated query. Look at this. It's joining this sales transactions table to all the dimensions, the customer, the product, country, and the store, and the calendar over all the surrogate keys. So this should be pretty interesting as far as a execution plan is concerned. So notice now it's a very powerful concept. We read the plan, by the way, right to left. So all these steps is table scan on the customer table. If I recall, that's a very small table, so an index wouldn't help. Then there's a sort so that it can be joined to the output of the clustered index scan here with a merge join. Then next on deck is a table scan on the country table. So the country, the output of that table scan and the output of the merge join is combined in a hash match inner join. Then finally we have an index scan on the calendar table and a hash match between that index scan right there in the middle and the results of that first hash match. And then finally a scan on the product table. Notice a lot of zero costs, so that's good. And finally we need to scroll up, so it's a fairly big plan. A bunch of table scans, a lot of zeros, which is good, and they're small tables, that's why. And a last hash match to combine the streams, the hash match and the table scan. In a little dry throat there, my apologies. So that's the query plan. Looks like it's a good one. It's on a fairly large table. Let's execute the query. And 1, 2, wow, 3, 4 seconds. You would think it'll be a little bit quicker. Probably there's a lot of optimization to do, but it did it in 12 seconds. Okay. Okay, I guess I should update this column at least. We got, how many rows do we have here? 324,000 rows. Oh, in about 12 seconds, right? Just a little timing that you might want. Is there anything else we want to look at? We have another one more query. We'll just add the where customer full name is equal to Catherine Bijou. That's a nice French name. Let's look what the query plan is here. So we have a table scan. Let's just expand this a bit here. So where's our customer table? Oops. So we're still doing a table scan on the customer table. Of course, the customer table is fairly small. There's our clustered index. What is it? A seek. Oh, you can't see it. Again, the window here for recording is kind of small. And let's see the customer table. Let's just do a quick query on it. See how many rows we got. And well, there's 360 rows. And do we have an index? I don't recall. We do not have an index. So just for fun, why don't we create a index? Let me see. Let me go down the script. Did I already have this plan? No. So let's create an index on this customer dimension, a new index. Just a non-clustered index. We'll call it the primary key customer index. What happened here? Try it again. Primary key. Get those cap locks away. And we'll make it unique. And we'll just add the customer key. That's all we need to do. Click OK. So now we have a key there. Let's, excuse me, I'll scroll up here. I want to free that cache so we can see what the query plan will be now that we created the index. Okay, highlight that nice big query. Display estimated execution plan. Where's our customer table? And we still have a table scan, but that's okay. Small table, so usually when it's less than, 10,000 or so rows, it's not even going to bother with that index. So what we can do, just a little review, we can right-click on this index and delete it. And it's gone. Okay, let's get back and continue with our lesson.
Creating non-unique clustered indexes are the same as the prior cases, except that we include the clustered keyword, but not the unique keyword in the create index statement. Here is a grumpy tip. Have a dedicated file group and associated files for indexes to speed things up. On separate disks if possible. And here is a grumpy alert. These will also eat up a lot of disk space. And here comes a grumpy demo.
Grab a cup of coffee, gang. Here comes our next demo. Take it away, Professor Grumpy.
Okay, our fifth demo, we're going to create a non-unique clustered index with Tsql data declaration language command. Might as well free the procedure cache. We're in the correct data warehouse. Sales data warehouse, sales transaction history table. Let's take a peek here, just peruse it. It's more of a regular transaction table, just a customer number is the primary key. But let me see, do we have any indexes here? Well, we have a whole bunch of indexes: product category name, subcategory, and transaction date index, all inversion entries. So we already have the table, so we really don't have to, well, we want distinct. We want to make sure that we have distinct values. Okay, so if we drop the table, might as well drop the table and recreate it. All those indexes are now gone, by the way. So that's a good thing that I did this. Just kind of shows you that once you drop a table, all those nice indexes that were there, I'll just right click on this and refresh it, and the indexes are gone. So now we're going to, don't have to drop any indexes. We're just going to create an index called transaction date on this table based on the transaction date column. Remember, IE is means inversion entry. It's a type of index. It's as I was saying, it's a type of index that just gives you an alternate pathway into the rows. It doesn't imply uniqueness. So we'll create this clustered index. Create clustered index are the keywords. You give it a nice name. Okay, 6 seconds. Let's free to cache again. We have a query here that, well, it filters on the transaction date. Okay, so we're selecting a whole bunch of columns. Let's check out the query plan. Okay, there it is. And I have to apologize again for clipping the video there, but it's in the interest of visibility. Anyway, we did use the clustered index, cost of 100%. Let's execute the query. 1 second, 21,600 rows. So that's pretty good performance. And we did check out the query plan. What else do we have here? Is this the same query? This time we're using the between clause, or the between operation, I should say. We'll free up the cache right again. And let's see what this does. Display execution plan. I think in all these cases, it'll just use the clustered index 100% of the time. We execute it. Still pretty fast, a second. And that's it. So let's proceed to our next topic: create unique non-clustered indexes with Tsql.
Creating unique non-clustered indexes is the same as the prior case, except that we include the unique and non-clustered keywords in the create index statement. Specifying unique will ensure all index column value combinations are unique. This is optional, by the way. If duplicates are present, index creation will fail when creating unique indexes, and error messages will be provided showing the unique critical violations. I will discuss the other index creation options in the intermediate course modules in my Grumpy University this fall, so stay tuned. By the way, you can look them up yourself if you are curious. Here is another demo.
Grab a cup of coffee, gang. Here comes our next demo. Take it away, Professor Grumpy.
Now we're going to create those indexes that I deleted earlier. Okay, we'll start off by freeing the procedure cache. We don't have that index on the product table, so we're going to create the unique non-clustered index. Okay, there's the keywords. Call it AK alternate key product on the product table, the dimension assigned to the dimension schema on the product name. Let's see how this works. Okay, an index or, okay, I'm sorry, I apologize. We go to product. We're doing the product table first. We're creating it on these dimension tables. There's the product table, and there's the index. Well, all right, I gave away the punchline, right? I should have dropped it first and now create it. So that was pretty quick. Now we're going to go to the calendar table, create a unique non-clustered index on the calendar table called AK calendar date. And what are we going to do here now? We're going to rerun that query. But first we'll look at the query plan. See what we got going here. It's suggesting an index. We're missing an index. We're doing a clustered index scan on the sales transaction table, an index seek on the calendar table, which is good, and a table scan on the product table. So let's click on this green suggested index, missing index details. Okay, let's just highlight the actual template of the index, create index statement we're going to execute. And if we create this index, it's going to improve query cost by 92.05%. At least that's what it's telling us. So we might as well believe SQL Server. And come on. I never can line this up. Okay, create, we'll call it inversion entry, i.e. inversion entry, and it's going to be on the transaction amount and tax. So we'll call it trans AMT tax. How's that for a great index name? And we're going to include not only the calendar key, but the sales transaction amount and the sales tax amount. Now I'm trying to remember here if on the calendar table, let's go look at that calendar table. Okay, dimension.calendar. What do we have an index on? Oops, those are the columns. We want to look at the indexes. And do we have one on the date? We sure do. That's the first one. So let's create this index that it's suggesting to create. Let's highlight the query here. Look at the query plan. What do we got going here now? Was there any improvement? Well, the green tip disappeared. So now we're doing an index seek on the calendar table, an index seek on the sales transaction table based on the date, and low costs across the board, except for the final hash match at 51%. So let's execute this query. And we get 21,600 rows in 1 second. So that's not too shabby. Okay. What else do we have here? We have another query that has a filter on the date and also the product name. Let's do a query plan on that. Index seek on the product table. That's good. No suggested indexes. What else do we get? A row ID lookup on the product table. Also interesting enough. And an index seek on the calendar. Index seek on the transaction. So across the board, a lot of indexes, most of the indexes are being used. So that looks pretty good. Let's execute this query. And we got 360 rows in under a second. So that was a good plan of action to have all those indexes available. All right. What are we going to do next? Create non-unique, non-clustered index with Tsql. So let's go back to our lesson.
Okay, we discussed creating non-clustered and clustered indexes with Object Explorer tools. Don't worry about the advanced stuff for now. We can also create non-unique, non-clustered indexes with Tsql DDL commands. Not specifying unique will allow duplicate values in the index. You can also include optional creation parameters within the parenthesis of the with clause, as shown in the clip. Here is a grumpy tip. A helpful option is to specify sorting in the tempdb database by turning sort_in_tempdb on.
Grab a cup of coffee, gang. Here comes our next demo. Take it away, Professor Grumpy.
Okay, here's our demo 7. Let's create some non-unique, non-clustered indexes with Tsql. We are going to still work with that table, the sales transaction history table. So this time we'll create a non-clustered index on the product category column. So let's just expand this sales transaction table. There it is again. In the sales transaction history, let's refresh our indexes folder, and we only have one, so we don't have to do this drop index exists, but we can also execute these as a batch if it did exist. We're also going to create one on the product subcategory column. Okay, remember now this is not really like a fact table, it's more of a transaction table because there's no surrogate keys. So let's create that index. Okay, getting a lot of indexes here. We're going to also create one on the product name, create non-clustered index, i.e. product name. I think that's all the indexes we want to create. Refresh our index folder. Okay, looks pretty good. DBCC, what does DBCC stand for? Database Consistency Check. And we're going to free the procedure cache. Make sure there's no plans in memory that can affect the generation of the query plan. We're going to pretty much pick out all of the columns from the sales transaction history table, where product category equals Italian trains. Okay, by the way, I'm a big model train collector, so I always come up with these model train schemes. But anyway, let's go look at this display estimated execution plan. And pretty much it just went ahead and just used the old clustered index. Let's execute this. Okay, that was quick, 27,000 rows. And you have a clustered index, it's going to pretty much use that all the time. Okay, we freed the procedure cache again. This time we're going to throw in the product subcategory also. We want to see some Italian freight trains. Let's look at the query plan. Okay, what do we have here? We added two of those inversion entry indexes there. So we're doing an index seek on the sales transaction history table twice. Okay, that's pretty interesting. And we're probably doing it on those product category, product subcategory. And we're just doing a bunch of merge joins and then a nested loop. Now we're doing a key lookup. Okay, when I do my course dedicated to performance tuning, when I create it, we'll really get in depth we should say on this and other tasks, right? So right now we just want some preliminary knowledge on how to generate query plans and what they mean. Okay, do we have anything else we need to do? Well, we need to free the procedure cache again. I'm going to try some other query. Oh, now we're adding product name, Italian freight rail cars, product subcategory, Italian freight cars or freight trains, and Italian trains. Let's see what this does. This should be fairly interesting. Wow, so we got 3 index seeks all on the sales transaction history table, and I think you can guess why, because we have 3 predicates in the where clause. So each of those index seeks corresponds to the product category, product subcategory, and product name column. Okay, so we're not using any of the columns in the, well, I take it back, we're not joining to that product table. So we're really not going to use anything. But let me see, is there anything in the product table, any columns that would be of interest? The product retail price. Okay, let me modify this query so that it includes a join to the product table to pull out the product retail price. So let's just fast forward while I build a query. Okay, so I modified the query. I joined it to the product table. I'm joining on the common product name column that's common to both, and I'm using the same where clause predicates. Let's rerun this. Well, actually, sorry. DBCC, where are you? There it is. Let's clear up the procedure cache. And let's see what the query plan looks like. There you go. We got an index seek on the product table. That was good. Also row lookup, and then we got all those nice index seeks on the sales transaction history table corresponding to the product category, product subcategory, and product name. So this is a pretty interesting query. It's an interesting query plan. Let's execute this query, and we get 5,400 rows in less than 1 second. So that was pretty impressive. At least I think so. Okay, let's go back to our lesson.
Can you alter an index once it is created? Yes, one way is with SSMS and SQL Server Management Studio. To modify an existing index in a SQL Server database table using SQL Server Management Studio, SSMS, you can follow these general steps. Step 1. Open SQL Server Management Studio. Launch SQL Server Management Studio and connect to the appropriate SQL Server instance. Step 2. Navigate to the Object Explorer. In Object Explorer, locate and expand the database containing the table with the index you want to modify. Step 3. Locate the index, expand the tables folder, then expand the table containing the index you want to modify. Locate the indexes folder under the table and find the index you wish to modify. Step 4. Modify the index. Right-click on the index you want to modify and select Properties from the context menu. This action opens the Index Properties window. Step 5. Adjust index properties. You can modify various index properties in the Index Properties window. Depending on your requirements, you can adjust index key columns, included columns, fill factor, and other index options. Step 6. Save changes. Once you've made the necessary modifications, click the OK button to apply the changes and close the Index Properties window. Step 7. Verify changes. After modifying the index, you may want to verify that the changes were applied as expected. You can do this by querying the System Catalog views or right-clicking on the index again and selecting Properties to review the updated index properties. Step 8. Test performance. It's good practice to test the performance of the modified index to ensure that it meets your performance goals. You can do this by executing queries that utilize the modified index and analyzing their execution plans and performance metrics. Step 9. Monitor and tune. Keep an eye on your database's performance over time and adjust the index configuration as needed to optimize performance. Following these steps, you can successfully modify an existing index in a SQL Server database table using SQL Server Management Studio. Remember to exercise caution when changing indexes, especially in production environments, and consider testing changes in a development or staging environment first. Let's try this out in our next demo.
Grab a cup of coffee, gang. Here comes our next demo. Take it away, Professor Grumpy.
Okay, now we're going to alter an index with SSMS. And let's, should we create a new one first? Now let's pick one here. We'll pick the product name, right click on it. What do we want to do? We want to rebuild it? No. Let's see. Rename it? No. Let's go to properties. And what can we do here? We can make it unique, but this probably wouldn't work. You can change this. You can change the order from ascending to descending, but let's keep it at ascending. Okay, the size, identity, allow nulls. We're not allowing nulls, but let's change it to a null, to allow nulls, but we can't. It takes the null, I guess, indicator from the column name. Okay, so let's see. We can go to options, allow row locks true, sort and temp DB. Here we go. Let's just make this true. Fill factor. Let's change this to 80%. Pad indexes. Okay, we can change padding indexes. Again, look up what all this means. The goal here is just to let you know you can do a lot of changes to an index, you know, with SSMS or with Tsql. So let's see. Let's just click on OK. To apply changes, the index will be rebuilt. Very good. And it's been rebuilt, and we should still be good to go. So let's apply DBCC procedure cache, and then let's look at the query plan. No, we don't want to do this way because it'll do a query plan for the DBCC procedure cache. So let's just do a query plan for the query. Everything should be okay. Index seek on the product table, low cost 1, and oh, this is a very very nice query plan again. As we recall, have index seeks on each of the columns, a couple of merge joins here, or I should say one merge join at 8%, another merge join at 18, all fairly low cost. So this is a very efficient query. Has nice index coverage. Okay, so that's it for our, well, actually, no. Okay, we altered that index. One last thing I neglected to show you is we right-click on it again. Look at the properties. Let me see if it'll let me script the index here. We'll script it to the clipboard. Let's see all the changes that we did with SSMS, and what happened? It did not go into the clipboard. Okay, let's do it again. Nothing like doing it the second time around. Script, index, to a new query editor window. Let's see what that'll do. Click on OK. Didn't go anywhere, did it? Do I have a new query editor window? No, that's surprising. Okay, let's get rid of this query. And let's, third time's the charm. What are we going to do here? This time we'll script the index. And we'll create it to the clipboard. This time it worked. So that was puzzling that it didn't work that way. I'll have to research that. That's all I can tell you. So here's what the new index now looks like. Okay, let me just make it a little neater here. And notice that it's now added the pad index off, statistics no compute off. It's going to basically put all of these here. Sort in temp DB is off. We'll allow it. Allow page locks. There's our fill factor. Optimized. So I must have not clicked on sort in temp DB. Okay, so we'll just leave it at that. I can always come in here and make this on, and then I could go ahead and rebuild the index, doing a drop index if it exists. But we'll leave it like this. So there you have it. That's how you alter an index with SQL Server Management Studio. And next we'll see how to do it with Tsql.
The code snippets in the clip demonstrate different ways to alter a SQL Server index using the alter index statement. Rebuilding the index with dropping existing index is an online option. Alter index name on table name rebuild with drop _ existing equals on, online equals on. This statement rebuilds the index name on table name with the option to drop existing indexes and perform the operation online. Dropping existing indexes allows you to rebuild the index from scratch, and performing the operation online ensures that the table remains accessible during the index rebuild process. Rebuilding the index with additional options. Alter index name on table name rebuild with drop _ existing equals on, online equals on, sort _ in _ temp db equals on. This statement is similar to the first one but includes an additional option, sort _ in _ temp db equals on. This option specifies that the index rebuild operation should use tempdb for sorting. It can improve performance for extensive indexes by utilizing the temporary database for sorting operations. Turning off the index. Alter index name on table name disable. This statement turns off the index name on the table name. Turning off an index prevents it from being used by the query optimizer. This can be useful if you want to temporarily suspend the use of an index without dropping it. Rebuilding the index with modified options. Alter index name on table name rebuild with sort _ in _ temp db equals on. Allow _ page _ locks equals off. This statement rebuilds the index name on the table name with modified options. It sets sort _ in _ temp db equals on, similar to the second statement, and allow _ page _ locks equals off. Setting allow _ page _ locks equals off disables page level locks on the index, which can be helpful in specific scenarios where page level locking is not desirable. Each statement provides a different way to alter an index based on specific requirements and performance considerations. When using these statements, ensure that you understand the implications of your chosen options and their impact on database performance and availability.
Grab a cup of coffee, gang. Here comes our next demo. Take it away, Professor Grumpy.
Let's alter some indexes with Tsql. It's going to be pretty interesting. We use the alter command. Recall, the alter command can alter tables and other database objects, but we're using it here to alter an index. So the syntax is alter index, the name of the index on the table, in this case our sales transaction history table that's assigned to the fact schema. We're going to include the keywords rebuild with online equals on. Okay, so let's execute it. We're going to rebuild the same product category index, but with different parameters. We're going to include online equals on, but we're going to sort in temp DB now. We want to ensure that any sorting that's performed with the index is done in tempdb. Imagine how fast that will be if you have a solid state drive. Okay, you can then alter the index and disable it. Let's see what that does. Let's expand on this. Product category index, where are you? Product category index. Right click on it. Look at the properties. And what do we have here? Any indication that this has been disabled? Okay, sort in tempdb is now false. Okay, any information here? Let's just click cancel on this. But let's do this one more time. Let's look at the properties. So there you go. This is what I was looking for. Forgive me. The index is disabled. There it is, right on top there, the little triangle, yellow triangle with an exclamation point. Okay, so now what happens? Well, let's try to rebuild it with sort in tempdb and allow page locks off, all these parameters. You can include all these parameters, by the way, when you create the index. So there it is. It's completed successfully. Let's look at the properties one more time. The index has been rebuilt and it's ready. As you can see, nice little blue circle with an exclamation point. Isn't that nice? Okay. Let's see. What else? Do we have anything else in here? Okay, we can drop indexes and create them. So let's get back to our lesson.
So, what have we learned? We learned how to use SSMS and Tsql to create table indexes, drop table indexes, alter existing indexes. It seems like an easy set of tasks, but there are a lot of options you can use and change. Typically, a DBA, which stands for a database administrator, would do these. Let's check out what else we learned. In this lesson, we also discussed the following: how indexes work, creating non-clustered indexes with Object Explorer, creating clustered indexes with Object Explorer, creating unique clustered indexes with Tsql, creating non-unique clustered indexes with Tsql, creating unique non-clustered indexes with Tsql, creating non-unique clustered indexes with Tsql. Query plans. We concluded that there are two types of indexes, unique and non-unique, and two categories of indexes, clustered and non-clustered. We must discuss when and when not to use them, or which is better in a particular table load and application scenario. Lastly, I will summarize the module in the next lesson by showing how indexes are used in a query plan. A query plan is a graphical display showing how the optimizer and query engine use or don't use indexes. Here is your homework. Make a copy of the daily_transaction table with the data in the hobby_shop database. Maybe call it daily_transactions_test. Create the following indexes on the table: a clustered index, a non-clustered index, a unique clustered index, need to drop the first clustered index, a unique non-clustered index. Execute some queries against this table by joining them to other related tables, mainly using cust_id and prod_id as the join columns. This is easy. Put all that new knowledge to work. The solution script will give you the shell of the join clause you need to do. Next, we look at how to generate query plans. We discuss what they are and what tools are available to generate them. We will discuss what these plans tell us about how the SQL Server query engines execute queries we write, and how to use the plans to perform performance tuning for slow-running queries. This is an essential tool, so take a 5-minute break, grab a cup of coffee, and see you in the next lesson.